Okay, we're going to try this out. I'm using a new software, so bear with me a little bit. We're going to talk a little bit about mirrors, and I have a progression of ways I would do things, but I'm going to jump around a little bit because a lot of the stuff I really want to do with you in person. We've got some great demos. I know you're going to really enjoy it when you see it. So just bear with me a little bit, and we'll figure this out. It'll be okay. So we are looking at chapter 35, which is about reflection. And we're going to start off by talking about light. And the idea with light, if you think about it, it's got to come from somewhere, right? And in general, if I say, where do you think light comes from? I'm guessing you might say the sun or a light bulb, and all those things are fine. That's absolutely right. Light, believe it or not, is a wave, and it's an electromagnetic wave. And I don't expect that phrase to make any sense to you. That's okay. It actually is due to vibrating atoms and electrons and all sorts of crazy vibrating things, and we're not going to worry about that either. So what we're going to think of is just think of the sun, and think of the sun as giving off rays. We're going to be talking a lot about these light rays, and we're usually going to look at it one ray at a time. And yeah, they are waves, and yeah, it's complicated, but let's just treat them like rays, okay? And what we're going to do first is we're going to look at mirrors. And there are three types of mirrors. There are the plane mirrors, which are the flat ones. These are the ones you're used to seeing on a daily basis, I bet. These are the ones in your bathroom or maybe in your bedroom, anywhere really that you think of, oh, look, there's my reflection. You're looking at a plane mirror or something that acts like a plane mirror. And there's a lot of cool things to do with that, and I will do a lot of it with you. But I'm hoping to see you on Wednesday, and we can do it then. In the meantime, I'm going to jump to a different kind of mirror, and these are curved mirrors that fall into two categories: concave mirrors and convex mirrors. Okay, so what I want you to do is hopefully you grabbed a spoon, and a soup spoon, and if you look at the part of the soup spoon that holds your soup or your ice cream or your cereal, that's going to be a concave mirror. So this would be you looking into it, and you'd be looking that way. And if you flip it around so that you're looking at the back of the spoon, what you're doing is you're looking at a convex mirror. Okay? And these kind of mirrors that we're going to be talking about today follow a lot of the same rules as of plane mirrors. There's something called the law of reflection that I'll come back to. But what they do is they behave differently based on where the object is. So let's go back and do some definitions. The object, you can think of that as you. That is usually the real thing that is in front of the mirror. That's a real thing. So if you are looking at yourself in the bathroom mirror, you're the object. We are going to actually use an arrow for our object because what you're going to see is sometimes that mirror, the picture of it, the thing you see in the mirror, sometimes it gets flipped upside down, sometimes it stays right side up. And so it helps to just think about the orientation of it. So what we're looking for is the image. This is what you actually see due to the mirror. So think about it a little bit. If you're looking in the bathroom mirror, right, you see something that looks just like you. Now let's think a little bit harder about this. Pretend you had no idea what a mirror is. You had never seen yourself in a mirror before. I don't know, you're on a desert island and you just have no idea what you look like. If you don't know what you look like, then chances are pretty good that you wouldn't put two and two together and say, oh, look, there's somebody that looks just like me in that mirror. You would instead think, oh, look, another person, hooray, this is so exciting. And look, they're just over there on the other side. But if you were to go investigate and look for them on the other side, you wouldn't find anybody there at all. That's an example of a virtual image. And what's happening is that your brain is actually playing a trick on you. Okay? It's a virtual image. That's a really weird idea. The more scientific idea is that it is a real image when the reflected rays of light, so you've got rays coming into a mirror and bouncing off, when the reflected rays actually converge to make an image. Also, with a real image, you can actually display a real image on a screen. Okay? And if and when I ever see you again, I will actually do a demo that shows you. The virtual image, this is what we see in our bathroom mirrors because it doesn't really exist. I can't use a flat mirror and actually make a picture of myself show up somewhere. Okay? I can do that with a certain type of mirror, but not a bathroom mirror, not a plain mirror. So the virtual image is basically what's created due to a trick of the mind. And let's say it's a trick of the brain, mind, whatever. Okay, the light rays do not converge to form an image. After reflecting. We just think they do. Okay, so let's do an example with a concave mirror and convex mirror, and you're going to do it using your spoon. Okay, so start out with a concave mirror with your spoon. Right, that's the side you're looking at the spoon, the side that holds the milk. Okay, see if you can do this. If not, we'll reenact it in class, but it'd be pretty cool if you could do it now. Hold the spoon like an arm's length away and find yourself in there. Okay, do you see you? Do you notice that you're upside down? Do you notice that you're really small? Okay, believe it or not, you're seeing a real image. For right now, you're just going to have to trust me on that. I'll prove it to you when I see you again. So there you are, upside down and much smaller. How do you know that you're smaller? Well, put your fingers and sort of find your head in the spoon, right? And it should be itty bitty, and then hold it up to your real head, and you'll be like, oh yeah, that's much smaller than my real head. At least I hope it is. Now what you're going to do is carefully bring the spoon towards you, and you should see that the image is getting bigger and bigger, and then it should get really fuzzy. And then if you keep going and bring it towards your eye, and here's a cautionary note, don't poke yourself in the eye, but bring it so it's almost touching your eye. If it's touching your eyelashes, that's actually the right distance. What do you see? Hopefully you see your eye. Hopefully it looks really big, and you might notice that it's upright. Okay, so when it's held far away, it's small and upside down. You bring it in, it gets bigger. It goes away for a little bit, and then when it comes up, it's upright and bigger. You can also, if you don't want to do this with your eye, you can also do it with a pencil. So, hold a pencil between you and the spoon, find the image of the pencil in the spoon, bring the spoon in, or I guess you could bring the pencil towards, and you'll see that it goes away, and then you should see that it gets really, really big and upright. And the pencil will be almost touching the mirror when you see that. Okay, now flip over so that you get the convex mirror. This is when the spoon is just, all I can think to describe it, it's the other side. It won't hold milk. All right, and as you notice, you hold it at arm's length and you bring it in towards you, so same deal. But here's the difference. You're upright, you should be upright the whole time, and you should be smaller the whole time. And if you don't believe me, do that trick again with your fingers, right? Measure the size of your head in the spoon, and then compare that to your real head. And I think you'll find that the image in the spoon is much smaller, okay? This is good. This is exactly what we're talking about. Okay, so let me just show you some other parts that you're going to be using. If we go back to the concave mirror, when you're going to be investigating it, we're going to look at a few things. There's going to be sort of an axis in the middle. We call this the principal axis. And then here is your object. And again, like I told you, we're going to pretend that it's an arrow. And then you'll have to forgive me because I'm freehanding this. Here is your concave mirror. If you look, if I brought that object in, doesn't it kind of look like it's going into a cave? So that's one way to remember it. Now you'll notice that the mirror also kind of looks like it's part of a circle. And every circle has a few things. It has a center, so we'll mark it with C, and it has a radius. And so we're going to call that distance R. So R, capital R, is the radius of curvature. And it is the distance from C, which is the center of curvature, So distance from C to the mirror. All right, you with me? Hopefully. If not, pause. If you need to go back, that's the beauty of videos, you can go back. Okay, the other important point is the letter F. It is the focal point. Capital F is the focal point. It is halfway between C and the mirror. That's the mirror right there. And there's a distance, little f, that we will come back to. Little f is what's known as the focal length. And this is the distance between f and the mirror. And some of you have done work with parabolae. What's the parabola? Well, at least one parabola you've worked with, and you might have talked about the focus of the parabola. That is not unlike our F here. The difference is that we're talking about a sphere, right? These are part of a circle, really, and so it's not parabolic. Okay, so the C and the F are inside the mirror, just like in this case the object is. So what if you're talking about a convex mirror? Well, the C and the F still stay on the inside of the mirror. It's just really that the object has moved. So we talk about the principal axis again. And again, here's our mirror. And here is maybe, let's see, maybe that's our C and maybe that's our F, and here's our object. When you'll be using these mirrors, I'm going to be giving you some ray diagrams, and we won't be drawing a circle, but it's just to give you a sense right now that this mirror is a piece of something. It is a piece of a circle or a sphere, if you like. Okay, so the convex mirror, the difference is that the object is facing the mirror like this. Obviously, hopefully you know that's the mirror. And the F and the C are still inside the mirror. Okay, that should put you in good shape to do the rest of the assignment, which is to fill out a chart. So I attached a chart and I posted it on Haiku. You should be able to look at that chart and fill it in and figure out some trends with concave mirrors and also convex mirrors. And hopefully this makes sense. All right, and I can't wait to see you because this will be much better in person. Okay, that's it. End scene.